Okay, so today we're going to be doing direct variation. Okay, and the way you'll see this worded is that X and Y vary directly. Okay, that means they change exactly the same every time in comparison to each other. There are two things that have to be happening in order to have direct variation. The first is you've got to have a constant rate of change. The second is that they have to be proportional to each other. Now, we did rate of change yesterday. So a constant rate of change just means that no matter what points you use, they all give you the same rate of change. Okay? There are some lines that don't necessarily go straight. You got crooked, it goes off and then goes up. So you might not have the same rate of change the entire line. But if you have the same rate of change no matter which 2 points you use, then that's called a constant rate of change. Okay, that has to be happening in order to have direct variation. Now, proportional means a fraction. That means X over Y has got to be the same for every single point on the line. Okay, so the two things you have to have for direct variation is one, a constant rate of change, and two, it has to be proportional. Constant rate of change means all the points give you the exact same rate of change. Proportional means Y divided by X always equals the same number for every single point. So an example. Here's a table. X is 1, Y is 4. X is 2, Y is 8. X is 3, Y is 12. And X is 4, Y is 16. So now, the first thing I'm going to check is my rate of change. So I'm going from Y to Y is plus 4. From X to X is plus 1. And I notice that as I move through each one, it's always plus 4 for the Y's and always plus 1 for the X's. That tells me that I have a constant rate of change because it's always the same. And that rate of change is the change in Y over the change in X. So the rate of change is 4 over 1, which is 4. Now I'm going to check and see if it's proportional. I'm going to put Y over X. So I put the 4 over the 1. I put the 8 over the 2, I put the 12 over the 3, I put the 16 over the 4. And if you notice, all of those give you the same number. All of those equal 4. 4 divided by 1 is 4, 8 divided by 2 is 4, 12 divided by 3 is 4, 16 divided by 4 is 4. So since they all equal the same thing, then that means this relationship is proportional. And if you have a constant rate of change and it is proportional, then you have a direct variation relationship. Okay, now let's look at direct variation on a graph. It's still the same two things that allow you to have direct variation. Okay, but it looks a little different when you're seeing the graph instead of seeing the points or the table. You still have to have constant rate of change. Okay, but in this case, constant rate of change makes it look like a straight line, because if the rate of change is always the same, then the line never curves or never turns. So a line, it's very easy to see that any straight line has a constant rate of change. The second thing is that it's proportional. Well, again, with a graph, very easy to tell if something's proportional, because the only way it's proportional is if it goes through the origin. Okay, this green line is direct variation. The red line is not, and the purple line is not, because the green one is straight and it goes through the origin. The red one is straight, but it doesn't go through the origin, so it's not direct variation. The purple one goes through the origin, but it's not straight, so it's not direct variation. Okay, now we are going to find the constant of variation, which we will call K. Okay, and it's just the proportional relationship between X and Y. It's just how you get from X to Y. In other words, it's just the number that you multiply X by to get Y every time. Now, so an example. Here's a couple of points. I have 3, 6, 5, 10, and 15, 30. So again, this is an X and a Y, an X and a Y, and an X and a Y. So if you see, I have to multiply 3 times 2 to get 6. I have to multiply 5 times 2 to get 10. I have to multiply 15 times 2 to get 30. Therefore, K equals 2. So my constant of variation for this relationship is 2. Now we're going to find K on a graph. Now first, a graph is made up of infinitely many points, so I'm just going to choose a couple of points that are nice to read from the graph and label them. Now, again, I see that I need to multiply 1 times K to get 2, 2 times K to get 4, 3 times K to get 6, and negative 1 times K to get negative 2, negative 2 times K to get negative 4. Well, there's only one thing that works for all of these, and it's all the same, and that's K equals 2. Now, I'm also going to find the slope of this line. So I'm going to use these 2 points. So I'm going to do rise over run. So I see that it rises 2, and then it runs 1. So rise over run is my slope. So 2 over 1 equals 2. Notice that I got 2 for both of these. K equals 2, and the slope, or the rate of change, is 2. So K is actually the same thing as the slope, or the rate of change. Now, here is your formula for direct variation. Okay, it's y equals kx. Any direct variation equation looks just like this. All you have to do is find k and plug it in where the k is. Okay, so for this example, we're actually going to write the equation for this table. Okay, so I'm going to do y over x to find k. Now, I know that it should be the same number for all my points, so I'm going to go ahead and write down all of them. And if you see, when I divide all of these points, I get 4. So k equals 4. But this time I'm wanting to write the equation. So I have to plug the 4 in where the k goes, and the equation for this table is y equals 4x. Okay, so again, in order to find k, I did y over x. I saw that it was the same number for everything, so that's my k value. I plugged that k in, and I've got my equation. Okay, so now here's some for you to practice. You're going to write the equation for these problems. This first one is giving you a couple of points. You're going to find k and write the equation. And the second one gives you a table. Again, you're going to find k and write the equation. And the third one gives you another table. And again, you are going to find k and write the equation. Alright, so for number 1, again, I'm doing y over x. So it's 4 over 2, because these are my y's, 4, 10, 12, and 18. My x's are 2, 5, 6, and 9. So I'm putting y over x, and I see that all of these give me 2. So that means k is 2. So the equation is y equals 2x. For number 2, again, I do the same thing. It's just in a table form this time. So I put y over x. It doesn't matter that x is larger than y. You don't put the larger number on top. You put y on top. Okay, and when I put all of those down, I see all of those actually equal 1/2. So that means k is 1/2. So y equals 1/2 x. Okay, it's perfectly fine for k to be a fraction. Okay, if k is a fraction less than 1, then that just means y is going to be smaller than x. Nothing wrong with that. And for number 3, I'm doing the same thing again. I've got y over x, so I've got 3 over 2, I've got 9 over 6, I've got 12 over 8, and I've got 30 over 20. When I simplify each of those fractions, none of them are whole numbers because they're all equal 3 over 2, which means k is 3 over 2, so my equation is y equals 3 over 2x. Alright, now I'm going to give you a graph, and you're going to find k and write the equation. Okay, you've got a red line and a blue line. Okay, you're going to find k for each of them and write the equation. Now, in order to find k, when you have the graph, all you have to do is find the rate of change, or find the slope. So I'm going to start with the red one, and I'm going to find my slope. I'm going up, rise 1, and run 3. Well, that means k is 1/3, because rise over run is my slope, 1 over 3, so k is 1 over 3. So that means the equation is y equals 1 over 3x. Now for the blue one, I'm going to start again at the origin and count my rise over run. This time I went down 2, so that's negative 2. I went right 1, so that's positive 1. So that means my slope is negative 2 over 1. So k is negative 2 over 1, which is just negative 2. So the equation for this blue line is y equals negative 2x.